here, you're taking a third-degree polynomial and dividing it by a second-degree polynomial. Your third-degree polynomial should have how many parts as far as terms are concerned? It should have 4, always n plus 1. Your second-degree polynomial should have how many parts in it? 3 of them. What's it missing? The x. So you always put a placeholder in no matter where. So you get x squared, 0x, and a 5. Then you have x cubed, 8x squared. We get to there. You've got to have a placeholder no matter what. And remember from here, you're always asking the same question. To start this problem, you always start by, what do I multiply x squared by to turn it into x cubed? X. So I put that above the x. And the other reason why we put placeholders in, because now I've got 3 parts here to match up with 3 parts under there. That's why that works. Okay? So you distribute that value of x. You get x cubed, 0x squared, and a 5x. Subtract each piece. Bless you. X cubed subtract x cubed, you get 0. 8x squared minus 0x squared, you get 8x squared. Negative 3x minus 5x gives you negative 8x. And then I have to bring down the 16. Okay. Too strong. Yeah. So now what do you multiply x squared by to turn it into 8x squared? Multiply it by a positive 8, because you always want to keep your signs the same. Distribute over. And subtract each piece. 8x squared subtract 8x squared, 0. Negative 8x subtract 0x is negative 8x. 16 minus 40, negative 24, I believe. And this becomes my remainder. So you take whatever that value is, including its first sign, and you put it over what you divided by. You don't have the placeholder. If you put the placeholder in there, that's fine. It doesn't make a difference. You don't have to put a placeholder when you put your remainder in there. Okay. When you check your work on these, depending upon what you look at, the remainder signs might change a little bit, especially if the first part of it's negative. Sometimes what they do is they might factor out that negative out of the numerator, and they might write it as minus the whole fraction of 8x squared, or excuse me, 8x plus 24 all over x squared plus 5. Sometimes they might just leave it like how I did with it, minus the 8x minus 24 over x squared plus 5. If you continue just to do it the way that I've been showing you guys without having to worry about sign stuff, you're gonna be okay. It's not that big of a deal, to be honest with you. Later on, I think I made mention. Did I tell you guys why we need to know about remainders? When we did hyperbolas, sideways, up and down, left and right, guess what they also do? They slant. So you get other slant aspects. This is when you do polynomial long division, you're able to find equations of the slant asymptotes for that style. That's not for a couple of weeks still, but it's the idea. This is one of the reasons why we show this one. Back into those other 5 out of the textbook. Was there any of the other ones you guys want to go through? Yeah. Fourth polynomial should have how many terms in it? 5. Third degree polynomial should have 4. Good. So we start by what you're dividing on the outside. So we have x cubed, x squared, 0x minus 5. And then we have 2x to the 4th, 2x cubed, 0x squared, 10x. Placeholders. El Nido placeholders. Necesitas muchas placeholderos. Anyway, so what do you multiply x cubed by to turn it into 2x to the fourth? 2x. Well, that's, I knew what she meant. You only need one of the x's, but you have to have number 2 in front of it. So you multiply that by, excuse me, by 2x, which means I place it above the 10x. Because I'm going to multiply this to 4 parts. Means I should have 4 parts below it. That's the other reason why we place them out like that. Okay. Distribute through 2x to the fourth plus 2x cubed, 0x squared minus 10x. When I subtract all 4 of those, what am I left with? 0. So what do I do with that minus 9? I just bring it down. So that negative 9 is my remainder. You're done. That's your remainder. Much easier than you guys are giving yourselves credit for. Yes, ma'am. Yeah. I'll get to that in a second. I'll get to that in a minute here. I just want to finish this up first, and then I'll go through that here. Give me like 2 to 3 minutes. Okay. Yeah.
How do you know whether it's like whether you have to if it's like less than what the first one is?
Yep. Because then you have to multiply by negative exponents. Right. Was somebody else saying one? Did somebody else want the other one out of that, or are we okay? Makes a lot of sense. What do you guys have? Watch the videos. Watch the videos and the notes and stuff like that. Okay. They go to the review packet. What about the 2 that were on the review packet? What's that? Now, with the 2 that were on here via the long division, neither one of them needed placeholder. So those should have been fairly decent, I hope. All right, for fun here. all that means, since we're not that far to be able to do all the rest of the dips and dives and stuff, even though we've talked enough about it, your tails down up, right? Tip. Right now, yes. And one of the things that I wanted to reiterate when we got to this part here is we are about 4 or 5 days behind where we've been in past. So we have, when I made this review packet. So this review packet I've used in previous years. It's nothing too crazy. We just haven't gotten as far as I'd like to because I needed, in order for this one to be completely good to go for you guys. I just wanted to make something real quick for you guys for last Friday. In order to make something real good, to make it up to where we were at, I had to back out the idea of sketch general shape. Sketch and general shape, when I ask you guys that stuff tomorrow, it's basically, what are your tails doing? Show me what your tails are. That's all I want to know. Okay? As we get further along, then we'll worry about zeros, specific heights and values and peaks and things like that. Okay? Yeah? Nope. Nope. Tails. I don't want f of x. I don't want to ever see you guys worry about f of x or anything like that. Tails. That's all I really worry about. Okay? I want to know tails. Okay? Also, I'll get there. I'm going to that one now. Also, if you look at number 22, 22 I think said solve for all zeros, I believe. Yes. Okay. Now, when you get into this one, there's not a whole lot that you can do. Okay. Because even if you try to group it 3 and 3, you have what times what's 3 and the other to get 2? Nothing. Okay. For us right now, you had to have seen another day's worth of stuff. We're almost to that. Number 22, you can't do yet. So don't worry about it. I'm not going to throw something on there like that for you. There's no reason. Okay. But if you look at number, which one is it? 19. On 19, I can ask you something more specific. Because we've done this. I think out of the whole thing on here, 22 is really the only one that you guys can't do. But at number 19, what if I changed it from zeros and state if there's any? If there is multiplicity, state so. What does that change? Yeah, nothing really. So when we get to one like this, if it says find all the zeros and let's say state any multiplicity, if so. When you have one like 19, you have a 5th degree polynomial. How many zeros can a 5th degree polynomial have? 5. Okay. What is the first rule of factoring no matter what? GCF. What do all 4 of those terms in that sequence have in common? X squared. So what I'm going to do right away is take the x squared out. Then I'm left with x cubed, 5x squared, 3x, and a 15. Now you're at a setup that you guys can all do with relative ease, actually, because it's 4 terms. You can factor via grouping. Group the first 2. What do they have in common? X squared again. Good. So we have an x squared out here. X squared. I'm left with x plus 5. If I group the 3x and the 15, what do those guys have in common? Pretty good. Factor out the 3. Are the 2 things in the parentheses the same thing? Yes. And like we said that's a really good sign. It's really good. Okay? So you're left with x squared, x plus 5, and x squared plus 3. That means we have enough info to state all of our zeros. Okay? One of them is really, really easy. -5. Now you're saying 0. Now with that 0, what does this represent? What does the x squared mean? Perfect. It means there's multiplicity. When x squared is written as a monomial, no plus or minus, no term, it's just the x squared, it's x to the 5th, x cubed, whatever. it means there's multiplicity at that value. In this case, you have 0 with multiplicity of 2. Just means it's there twice. This stuff. What do you mean? Okay. If it was 2x squared, it would still just be multiplicity of 2 because the constant has no variance to it. That's just a scalar. Sorry, I was trying to be polite. Nice. Okay. So I have 0 twice. There's 2 of my zeros. -5 once. There's 3 of my zeros. This one's going to be at plus or minus the square root I root 3. And the reason why it's I root 3 is because I subtract the 3 and take the square root. That's where I get the I value. So I have 5 zeros. Plus or minus I root 3, -5, and 0 twice. Okay. That's what that looks like. Not terrible. Yeah. Yeah. To be honest with you, number 22 is going to be really, really, really easy after about 5 minutes Thursday. Don't worry about it. Don't worry. It's going to be super easy after about 5-10 minutes on Thursday. Believe me on that. Okay, remind me to go back to 22. Save this, don't throw it out. Yeah. Give $1. You're going to cover it? Thank you. I wanted to make sure I did. I wanted to do one of those. Thank you for reminding me about 17 or 18. They're basically the same problem. Okay. Oops, that didn't work. Number 17 says find. This one says factor each, but yet since it says equals 0, that means you have to find the zeros. Now, instructions that I'll write up usually say find all zeros and state multiplicity if there is any, somewhere along those lines. If I say just factor, you won't have equal 0. It just means factor. Okay. Here, since we have the equal 0, we have to figure this out. Since this one is it's a trinomial, your exponents go from 8 and 4 to nothing. Treat it just like you would a regular quadratic. And think, what times what's 16? You add together, you get -17. Yeah, -16, -1. So this becomes x to the 4th minus 16, x to the 4th minus 1. Now, aren't those both differences of squares? Yeah. What's the square root of x to the 4th? X squared. What's the square root of 16? 4. Is that a subtraction sign? Yeah. So I get x squared minus 4, x squared plus 4, x squared minus 1, and x squared plus 1. What's that? You can keep on going, but in this case, if it was find all your zeros, can't they just stop here and just list all my zeros? You don't have to keep going though. You really don't. Because here, if you know that if the problem was find all the zeros, state multiplicity if needed, I can set each one of these terms equal to 0. So if I add 4, take the square root, I get plus or minus 2. I subtract 4, take the square root, I get plus or minus 2i. I add 1, take the square root, I get plus or minus 1. I subtract 1, take the square root, I get plus or minus I. It was an 8 degree polynomial. How many total zeros should I have? 8. 2, -2. 2i, -2i. 1, -1. I, -i. As 8 ceros. I'm an idiot. I get it. It's okay. Es muy importante. Que bueno. Tú necesitas un accente grande. Es muy mucho. Now, number 18 is exactly the same thing. They're really the same. Yeah. Tomorrow. I don't know. It's an assessment of sorts. We'll figure out what it is and we'll figure it out. I don't know. So what else we got? You should still prepare no matter what. Doesn't matter. The other one that was in here that I want to make sure you guys remember. Which one was it? Oh yeah. Look at 12 real quick. So I'm going to change this ever so slightly to make sure that we all remember how it would work. In this case, right now, it just said factor. And I'm assuming you guys all realize the first rule of factoring is to do what? GCF. Then you probably recognize that it's a sum of squares. Are you okay with that? All right. I'm going to change this, and I'm going to ask that you find all the zeros to this, which means we're still going to do the same stuff, but I want to remind you guys, what do you do with the back end of a jump cube? Remember the pattern here. Not jump cube, I'm sorry. It's a sum or a difference of cubes. So just like you said, first step, GCF. In this instance now, since I changed it to equal 0, does that 2 have any bearing on the problem whatsoever? No. If it's an equal 0, you can disregard it. If it was just factor, if this was just factor, you'd have to bring the 2 along the entire time. That's the difference between those two. Okay, just so you remember. But I'm going to say, I'm going to keep it like that for right now. Now, I have to start to think about the pattern. The pattern for these things, something cubed, something cubed. Sum of cubes was a plus b, a squared minus ab plus b squared. Same change positive. Same change positive. Okay. What is the cube root of 125x cubed? 5x, yeah. So this is the same thing as saying 5x quantity cubed plus 1 cubed. So when I go to write this out, my value of a is 5x. So I get 5x plus 1. What is the quantity 5x squared? Very good, 25x squared. And then I have minus 5x plus 1. Okay. Once we get to the pattern, really easy. One of those two is, again, a really easy 0 to find. -1/5, very good. The other one you have to math. Trinomial, can't factor it, quadratic. Okay. Quadratic formula. X equals -b plus or minus square root b squared minus 4ac all over 2a. So we fill in the blanks. Okay. What is the opposite of -5? 5. What's 5 squared? So we start piecing it all together. When you start piecing it all together, when you're working with the sums or differences of cubes, you should get some decent values underneath the radical. They shouldn't be all that bad. They really should. So what's 25 subtract 100? -75. Now, isn't -75 a number you could probably figure out the square root of? Okay. What's the perfect square that's hiding in 75? 25. So that means the square root of -75 would be have an I in it. It would be what? 5i root 3. Okay. So I'm going to write this over here in a little bit more space. I'm going to get 5 plus or minus 5i root 3 all over 50. All of the coefficients now have something in common. They all have 5s in common. This is where most of you guys will make a mistake. Okay? That's why I'm trying to remind, that's why I'm reminding you of this here. When something like, you guys all see that these guys all have some sort of GCFs here. There's a 5 in them. It could be a 4 in them, 2, whatever. Now, what I would do is this. Take the 5 out of the numerator. I get 1 plus or minus I root 3 over 50. By taking that 5 out of the grouping of the numerator, now I'd be less likely to forget that I can simplify over all parts. Because what's 5 over 50? So your final zeros here, we had negative 1/5. Then we get 1 plus or minus I root 3 over 10. You only do it to one of the 5s. You won't do it to both. What's that? If you do it to both of the 5s, it means you have to remember to divide each part out by the 5. What do those two I guess in common? They have 5, right? Think of it this way. What if it was, what do those guys have in common? So by factor of 5 out, isn't that the same as saying, it just so happens it had a whole lot of other crap involved with it. You had the plus minus, you had an I value, you had a square root. But as long as those coefficients all had that same value in common, just do it. If this was 5 and a 15, this would have been a 3x there. Does that make sense? It's a lot easier to take care of that numerator first before you try to do all of it at once. It's just knowing where you guys make mistakes. That's what I do. What else have you guys gone through or seen or a style that on this real quick that's messing with you? Oh, real quick, one thing that I neglected to throw on here just because we ran out of space, figured you guys weren't doing too terrible with it, is when you're doing the exponent rule stuff. Simplifying the monomials.